Hey, what's going on, guys? Let's try this problem right here. Here what we are going to do is we are going to find out unknown currents, unknown mesh currents and unknown branch currents using mesh analysis method. Now in order to do mesh analysis method, we have to follow all these steps. The first step is assign currents for each branch. Now let's assign currents. So let's put our mesh currents first. So here we are going to have I1 and let's say this is I2. It doesn't matter which direction you put, because if you get a negative answer it means this is in the opposite direction, so it doesn't matter. And then this is going to be I3, right? Now we have three mesh currents and the third step, so this is second step. And first of all we have to know this current is going to be equivalent to this one, like whatever the current going through this one is going to be equal to I1, right? So this is small I1 is going to be equal to big I1, and here we are going to have I2, and this one is going to be I3, right? And then here we are going to have, let's say, I4 and I5 and I6, right? So this one also, the direction doesn't matter. If you get a negative answer, you can always assume that's opposite direction. You can say that is opposite direction, right? Now the third one is apply the Kirchhoff's voltage law to obtain equations. Now Kirchhoff voltage law says that addition of all the voltage in the mesh is going to be equal to 0. So first of all, if I take this mesh, I1 mesh, let's say mesh 1, right? Mesh 1. So if it goes from negative to positive, that's going to be a positive 16, right? So positive 16 voltage. Now let's avoid this voltage sides, just put the numbers only, that way it will be easier, right? So here we are going to have this one 16, and then this I1 goes through this 4 ohm, so 4 ohm, so this is going to be 4 I1, right? Now let's, okay, 4 I1 along the path, so that's going to be negative I1, and this is, if you see the I3 on top is going to go through this one opposite direction, so opposite direction is mean it's going to be positive. Now here we already have the negative, so if we put another negative, that's going to make this one positive. So here we are going to put negative I3, and now this is going to be positive, because negative negative, that's going to be positive, right? And then this I1 goes through this 2 ohm, and if you notice this I2 also going through this 2 ohm. I1 is going along this path, along this I1's path, so that's going to be negative I1, and I2 is going against the I1, so this is going to be positive. So if I put a negative, that's going to make this one positive, right? So negative I2, and also 2 I had to multiply by 2 ohm, and this one also I had to multiply by 4 ohm, right? 4 ohm, and that's it. That's all we have. So this is equal to 0. So this is our first equation. Now let's look at the second mesh. Second mesh we have, let's start from this one, right? This middle part. So here we have I2 goes along this one, so that's going to be minus I2. And I1 is going against I2, so this is going to be positive I1. So if I put a minus, that's going to make this one positive I1. And the resistance in between is 2, so we have to put 2 in front, right? And then after this is going through this 8 ohm, so it's going along the 8 ohm, so this is going to be minus I2. So let's put the 8 in front, minus 8 I2, and I3 is going opposite to I2, so that's going to be positive. So here we put negative, so that would make this one positive, right? Negative, negative, positive. So we are going to put I3 right here. And after that, this I2 goes along this 40 volt, and now this is going from positive to negative. So this is going to be negative 40, that's equal to 0, right? And in some books you will see it's exactly opposite signs. In both ways it's correct, because if you put minus 16 plus this one, you will get the same answer, right? It's like multiplying this one by negative 1. Now let's look at the third mesh. Third mesh, let's start somewhere, like let's start with 6 ohm. So 6 ohm is along this I3, so that's going to make this one minus 6 I3, and then after that it goes through this 8 ohm, so along 8 ohm, so this is going to be minus 8 I3, and here this I2 going opposite of this I3, so this is going to be positive. So if I put a negative right here, that's going to make this one positive, right? So this is going to be negative I2, and after this I3 going through this 4 ohm, so 4 ohm along the 4 ohm, so that's going to be negative and 4 I3, and this I1 is going against the I3, so that's going to make this one positive. So we have to put a negative because we have negative, that's going to make this one positive, and that's going to be negative I1, and that's equal to 0. Right, now we have three equations. Now all we have to do is write the simplified form. Now let's look at the first equation. Let's go from I1, I2, I3, right? So here we have negative 4 I1, negative 2 I1. So totally we are going to have negative 6 I1. And let's count the I2. So here we have positive 2 I2, and that's the only one, right? So this is going to be positive 2 I2, and we have to count I3. So this is going to be positive 4 I3, and that's it, right? Positive 4 I3, 4 I3. And if I move this 16 to the other side of the equation, that's going to make this one negative 16. So this is our first equation. Now let's look at the second one. Negative 2, negative 2, negative I1, that's going to make this one positive 2 I1, and that's the only one we have. So this is going to be 2 I1, and let's count I2. So here we have negative 2 I2, negative 8 I2, that's going to make this one negative 10 I2, right? And this third one I3, we have positive 8 I3, right? Positive 8 I3, that's equal to, if I move this negative 40 to other side, that's going to make this one positive 40, right? Now let's look at the third equation. Let's count the I1. Here we have plus 4 I1, and I2, here we have negative 8 and negative I2, that's going to make this one positive 8 I2. And I3, here we have negative 6 I3, negative 8 I3, that's going to make this one negative 14 I3. Negative 14 plus negative 14, negative 4 I3, that's going to be negative 18 I3. Negative 18 I3 is equal to, so we don't have any number right here, so that's equal to 0. Now we have three unknown variables. Now to solve this one, we can use Cramer's rule. Cramer's rule is basically we take the determinant and determinant of the original form, and then whatever we are trying to find, we swap this one. Like if you want to find I1, you swap this one and find the determinant, right? And then divide by the original determinant. Now let's find the original determinant first. To find the original determinant, what we do is we only take the, let's put this one in matrix form. First, what we do is we take this matrix form, minus 6, 2, 4, and then 2, minus 10, 8, and then 4, 8, minus 18. And the easiest way to do this Cramer's rule is cross multiplication. Like if you have to write the first term again twice. I mean again first two terms again. So this is going to be minus 6 to 4, and then we are going to have 2, minus 10, 8, right? So here, okay. So here what we are going to do is we are going to do the cross multiplication. So we cross it like this, right? And the second one like this, and the third one like this, and then we subtract other crosswise, like last three matrix, like this, like this, like this. And if you cross the first one, so negative 6 times negative 10, positive 60 times negative 18, if you multiply you will get minus 1080, right? And the second one, you're going to have 2 times 8, that's going to be 16 times 4 plus 64. And then we have 4 times 2, 8, 8 times 8, again 64. And then you subtract, right? And the opposite side, 4 times minus 10, 4, that's going to be negative 40 times 4, that's going to be negative 160, right? So here we're going to have negative 160, negative 6 times 8 times 8, that's going to give you negative 192. Negative 6 times 8 is what? Negative 8 times 6, 48. 48 times 8. 48 times 8. Yeah, that's going to give us negative 192 plus. No, not 192. It's actually 384. 384. And then 2 times 2, 4. 4 times 18. That's going to give us negative 72. And if you calculate all of them, you will get negative 336, right? Now this is our original determinant. Now we have to swap. Like if you want to find I1, you have to swap this term, this one, and write this. So the matrix is going to be minus 16, 44, and then we are going to have 2 minus 10, 8, plus 4, 8, minus 18, and then we have to write the first two terms again. That's going to be minus 16, 44, and then 2 minus 10, 8, right? Again we are going to do the same type of crossing, like this, and then opposite is going to be last 3 terms. So that's going to be this one, and this one, right? And if you calculate this one again like this, you will get these values. This one is going to be negative 2880 plus 1280 minus 0 minus 1024, and then minus 1440, and if you calculate you will get 864, right? Again, to find I2, you have to do the same step, and that's gonna give. So this is I1, right? I2, you have to follow the same step. For I2, you have to swap this one, this one, and write the matrix like this. And if you do the Cramer's rule, you will get 2592, right? And for I3, you have to swap this one with this one and do the Cramer's rules. You will get, not Cramer's rule, we are finding the determinant after we do the Cramer's rule, right? So here, if you find the determinant, you will get 1344. Now we are going to do the Cramer's rule, like we have all the term, right? Now first one, what we are going to do is to calculate I1. I1 is going to be equivalent to this value. So whatever the determinant we found after swapping with the first column, that's 864, right? So 864 divided by the determinant of the original form, that's minus 336, and that's going to give you negative 2.571 ampere. And I2 is going to be, again we have to 2592 divided by minus 336, that's going to give you minus 7.714 ampere. And I3 is going to be 1344 divided by minus 336, and that's going to give you minus 4 ampere, right? And that's it. So these are our I1, I2, I3. So these are mesh currents, these currents, right? Now here, if you notice, in this path, this capital I1 is the only one traveling through this. So small I1 is going to be equal to capital I1. And then in this path I2, and if you notice, I2 is the only one traveling through this. So small I2 is going to be equal to mesh I2, right? Branch I2 is equal to mesh I2. And I3 also same thing. This branch only I3 is traveling. So small I3 is equal to big I3. And what about I4? I4 is different because I4, I mean small I4, if you notice there's I1 traveling through this, I3 traveling through this, right? So I4 is going to be positive I1 because I1 is traveling along the I4's direction, the direction we assumed. So this is going to be positive I1, and I3 is against this one, so this is going to be minus I3, right? And if you calculate this one, we know that I1 is 2.571 minus, and I3 is minus 4 ampere, so again minus 4 ampere, and if you calculate this one you will get 1.429, right? And you have to do the same thing for I5, I6. For I5, this is going along the I2's direction, so I2 positive, and I3 is going against it, so it's going to be minus I3, right? And I6 is going to be I6 is going along this I1, so that's going to be positive I1, and I2 is going against it, so this is going to be minus I2. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.